So here we are, and I was trying to tell you about PDBs. So the PDB is the database as far as the application is concerned. But what's new in multi-tenant is that these PDBs can be very easily moved around the place. That's the portable part of them. So you can move them between CDBs, container databases. That's very, very useful for all sorts of good reasons, which we shall soon see. And you can create new ones very, very easily. That's what we call provisioning. And you provision them as clones of either an empty database, that's how you set up a new empty database, or an existing database if you wanted a copy of something in production, something like that. So that's what a PDB is all about. And that's the database, as I keep saying, as far as the application is concerned. The database as far as the administrator is concerned is the container database, which has multiple PDBs plugged into it, potentially. We call that the CDB for container database. And the whole point is that you can manage many as one this way, because the DBA thinks of the entire container database as the object which he or she has to administer. So when they do things like a backup, you set that up once at the level of the CDB, and you're backing up all the PDBs. Nice and easy. Same with patches. You apply patches centrally, upgrades, configuration for high availability, which is what we call HA. Those sorts of things you do at the level of the CDB. So it's much, much easier. So a great deal of the operations that a database administrator or a DBA does become much easier because you can manage them together. But you retain granular control when appropriate. And that's very useful because, you know, sometimes you really do want granularity. Sometimes you might want to do like a point-in-time recovery or something for just a single database. So we can do, you know, you kind of got the best of both worlds here. And the technical efficiencies you get because you've got a single operating environment. So we've only got one SGA, this shared memory area, across the entire CDB, and it's shared between all the PDBs. You've got one set of backgrounds. And what this means basically is that you're not replicating all of this infrastructure of a database for every PDB. You've only got one set of these things. And by eliminating this unnecessary replication of overheads, it leaves a lot more processing available for the actual application workload. And therefore, you can get more applications per server. And it's cheaper, it's much cheaper to run. So that's the basic overview of the architecture. And then we start talking about some use cases, and there's a classic way to start. So you might think about this, Tyler, for your shop, and anyone that's just starting. I'd say start with dev and test for all sorts of good reasons. Apart from anything else, the very people that you want to become experts in this new technology are using it in their day-to-day operations. So that's a good idea. These are the first people you want to become expert. Second, by definition, it's not production. And if you're risk averse, you might say, well, I don't really want to start with my, my trading system or my air traffic control system or my nuclear power station management system. I'd like to start with something a little bit lower risk, please. Dev and test is a good place to start from that point of view. So it's a good place to start. And in fact, the advantages I was just talking about, reducing operating expenses because you can manage many as one, reducing capital expenses because you can get more applications per server, they're particularly true in development and testing. The classic use case for this might be that, let's say you've got a production container database, but in development what you like to have often is what we call a development master or a golden master database. So you set this up as, let's say, a clone of production, and that sits there. It's we call it a golden master, from which you can provision individual clones. So a typical thing that development shops do, you know, afterwards I'll open up and we can discuss this one. You know, I used to work at Siebel, and at Siebel, one of the things that my group was responsible for was managing the development environment for all of our developers, and we had thousands of these guys. And typically what would happen is we would do a build every night, the latest version of the product we build every night, and we would have 5 master databases. There was a development master, a test master, there was a demo master, there was a copy of production, which is what I've just illustrated here, and there was something we call the volume database. So those were our 5 masters. So every night we do this, the new build, we would upgrade the test masters, just that little incremental upgrade between Monday night and Tuesday. And then in the morning, conceptually, everyone would come into work and take a clone of the latest version of the database. And then they go ahead and do their work. Let's talk about the QA guys, for example. So they take the latest copy of their test database, and they'd run a whole bunch of tests against them. And sometimes they might top it up with their own test data, that sort of thing. But practically the way that worked was that it didn't make any sense to come in and start that at 9 o'clock in the morning when you get into work, because if 100 people are doing that, it takes literally hours to import all these databases. Back then we were using imp and exp to import these clones of databases. We're talking about 15, 16, 20 years ago. So what people did instead was to set up a cron job, which would kick off at 4 in the morning. And that would sort of restore their databases so that by the time they came in, it was ready for business. But if that cron job failed for some reason, maybe the build hadn't finished, everything would fail because there was nothing to clone from. You come into work and you're faced with 2 bad options. Bad choice number 1 is that you start your refresh then, and it takes 2 or 3 hours. And, meanwhile, you've got nothing to do. And all your friends hate you because you're thrashing the I/O subsystems, but while you're doing all these imports. That's a pretty bad idea. Or bad choice number 2 is you use yesterday's build. And some of the time you're going to get away with that, but sometimes not. And the classic problem that would happen is you do a test against yesterday's build, everything seemed to be all right. But what you haven't done is to catch the regression that happened in last night's build because you're using yesterday's build. So it's a nightmare. Much better than that is to be able to use just a few full copy databases, those 5 I talked about, and take what we call snapshot clones. And a snapshot clone is apparently a full dataset copy of your source database, whether it's a production or a test master or whatever it is. Apparently, it's a full dataset copy. Behind the scenes, we're cheating. We're using copy on write technology, which basically means we're using the same data blocks. We didn't need to replicate the data blocks. We just created the illusion of copying the files by copying just the headers. It's well-established technology, works very, very well. And we leverage this with what we call snapshot clones. So the example I was talking about with Siebel there, in the modern world, what we do is you take these snapshot clones, which happen in just a matter of seconds to give you extremely, copies of, even extremely large databases just in a few seconds. So it's much more practical to use. And since it's so cheap to create these databases, you can use them, you can throw them away, you can start again. It's very, very efficient. So dev and test is a great place to start. It's efficient in the example I've been giving because of storage. It's very efficient because of memory. And to talk a little bit about memory, do I have a slide about this? I haven't. To talk a little bit about memory, if you think about what you're doing with dev and test, there's an awful lot of think time and not a lot of compute time, particularly true for development. You're typing in a SQL statement, that might take you a minute or so. You might get a few rows back. The computer's doing nothing. But if everyone's working in their own isolated environment, everybody, and in 11G, or maybe go to Amazon or something and pick up an Oracle database there from Oracle, from Amazon RDS. You can do that. But the footprint of that database is about 3 or 4 gigs. That's about the minimum size of a VM to run an Oracle database. And what quickly happens that way is you run out of memory in your system. Even though your CPU is doing nothing, you run out of memory because, let's say I had a good customer doing this. Let me see now. It was Cisco UCS blades with 96 gigs of RAM. 6 times 16 is 96. So they use 6 gig VMs. They got 16 databases on a machine, and that was the most they could get. They were out of memory. Even though the CPUs weren't doing much, they need to have a new blade. And even if you think, for Cisco, that's not a problem. They've got these blades just, in their top drawers, just take a few more out. Well, it's not that way. They've still got to pay for their software, and they're paying per processor. Even though the processor isn't doing anything, you've got to put a new one in, So dev and test, do it with multi-tenant. You can get far more PDBs per CDB. In the Cisco case I was talking about, they got 50 developers on the very same blade with everyone using a PDB. So it's much, much more efficient. So if you're wondering where to start there with dev and test, and you'll be happy you did so. And your developers, when they want a new database, instead of asking the DBAs to create a new one for them, you might want them to come to some simple self-service interface. So this is another use case. I call it dev and test. I'll quickly pause and look at the chat here. Who's chatting to me? Snapshot clone support for ASM. Okay, good question. Fuang, does 18C Snapshot clone support ASM directly? Yes, it does. Actually, we've done this since 12.2, I think. So Snapshot and ASM on Exadata is fully supported, and the restriction there is that the source remain read-only. But for the use case I'm talking about here, no problem. You're talking about a golden master. So, by definition, you don't want to change that one. It sits there, you leave it read-only, you take clones from it. ACFS can also be used for doing snapshot clones, but ASM works too. But the typical usage is going to be the same thing. It's going to be a database as a service model, which is what I'm illustrating in this slide. And the idea is that rather than getting some DBA involved, the developer comes along to some simple interface and says, I want a database. I'll have a medium one, please. I don't really need much availability. I'll just run it at the bronze level. And the idea is the infrastructure just provisions that database, the right database in the right CDB for you. And then you're off to the races. No human intervention required. Pretty good stuff. And use the same sort of interface, sorry, to change SLAs. If you want to move from bronze to silver, click a couple of boxes, and we change the SLA by moving the PDB into a CDB which is pre-configured for the higher level of availability. In this case, let's say silver. A lot of people use these Olympic medals, right? So bronze is the basic one, silver is better, gold's the best. So silver is more highly available because it has RAC, real application clusters. If one of the nodes fails, the other one is available for instant failover. So it's higher availability. That's why it will be silver. So what you do is you pre-configure these CDBs for the appropriate availability level, and then you just plug the PDB into the appropriate one. So if you wanted to move from silver to gold, let's say, where we're protecting even against media failure by keeping a standby at some remote location, that's with DataGuard, I really want the top level of availability, fine. We'll move from silver up to gold, and again, it's an unplug-plug operation. And that's how it works. So database as a service is a classic way of operating a cloud-type environment based on multi-tenant. We specifically designed this architecture for the database cloud, whether it's running in our cloud or your cloud. We think this is the right way to do things because the efficiencies, the technical efficiencies, the operation efficiencies, and in this case, we're talking about agility as well, just so much easier. So then another use case, so somebody mentioned that you're doing consolidation, basic consolidation. This is a classic thing. You've got a whole bunch of different applications running at various different versions of Oracle. And if you're going to be euphemistic, you might say that we've deferred maintenance a little bit, which is a nice way of saying that maybe we never maintain some of these databases. You're behind on patches. You don't back them up as often as you'd like. It's really a disaster waiting to happen. And typically, that's not a problem at your top tier databases. The problem tends to happen at the lower tier databases. Obviously you spend more money on the more important databases. But from a compliance point of view, it's the weakest link in the chain that matters. Any unpatched database is like leaving your back window or your back door unlocked. That's where the thief is coming in. They're not coming in through the front door. They're going to find some vulnerability in your system. There's a whole bunch of known vulnerabilities in technology. We all know this. And if you don't patch, then you remain vulnerable to those things. So what the hackers are going to do is they're going to look for the old databases, and they're going to hack in that way. And as soon as they're in, and then you're in trouble. So what multi-tenant allows you to do is to remain in compliance much more easily. And this is where this classic use case of consolidation of disparate applications comes in. You might say, look, I've got this whole hodgepodge, in this case, half a dozen databases. Well, why don't we just create a single container database? Let's even manage it at the silver level. So right now we've got a whole bunch of databases to manage, and that's the problem. We've got 500 databases to manage. We only really ever get to maintain 400 of them, and we neglect the other 100. These days, what we can do is we can upgrade them all to 12c and adopt them as PDBs. Now you've only got one environment to manage. So one environment to patch, one environment to back up. But most importantly, from a client compliance point of view, we're talking about patching here. So you patch all of these guys in one fell swoop, and everyone stays up to date. And it's a major relief, I think, to the compliance officer, the chief security officer. These people, I don't know how they sleep at night, because you've got these, all of these vulnerabilities coming to light all the time, Spectre and Meltdown and God knows what. You've got to patch all those environments before the hackers get to exploit these known vulnerabilities. So we make it so much easier to stay in compliance by dramatically reducing the number of environments that need to be patched. And as a bonus for this, because of the multi-tenant efficiencies, you can get more applications per server. You consolidate all of those into a single environment. You'll probably find that you got some available capacity. So this is great. And if you're coming from other environments, maybe with lower availability or performance or scalability characteristics, you can do what we've done with a lot of the acquisitions that we've made at Oracle, applications built against other database environments, upgrade them to multi-tenant. We've got a whole bunch of conversion utilities that work extremely well. And to the extent that you've already paid for that environment in which you've already got spare capacity, you can view that as a free upgrade, and you're back down to a single environment to manage. And now everyone's using an Oracle database with all the additional capabilities that we've got compared with the competition. So that's a very, very good use case. Now, 5 years ago when we started with multi-tenant, I thought that everybody was going to be starting with dev and test. But interestingly, a lot of customers have started. Northern Trust, for example, is a customer of ours, is a big bank based in Chicago. They started with production systems, and their philosophy was, we're building applications so fast that the only way we can keep up with the demands of the business is to build in the most agile way we can, which is on multi-tenant. So they just developed all of their new applications and consolidated them in multi-tenant. And later on, as they got up to speed, they've begun to migrate some of their older applications, which wasn't what I expected, but I think it's a great compliment that they've been so confident in what we delivered, and they've been very successful too. So now we come on to Fwang's use case of software as a service. And at a very high level, multi-tenant is great for this. I mean, you could say that the product is named for this use case. So if you think, what is the point of, or what are the requirements of software as a service? Well, the basic one is tenant isolation. And with the PDB, you've got built-in isolation. So you'd have a PDB per tenant or per customer. In your case, this would be your clinic or your hospital. And everyone's data is beautifully isolated in this same PDB. So in the healthcare space, we're talking about HIPAA typically. And these days, of course, if you've got any customers in Europe, of course, we've got GDPR as well. And the point with with HIPAA is that you require the isolation of each tenant's data. It's not intermingled. Each PDB is a self-contained, fully functional Oracle database. And by self-contained, I mean it's got literally its own table spaces with its own data files. So the data that belongs to customer one is literally in different data files from every other customer's data. Everyone is isolated from that point of view. So you're physically isolated in the data files. You can have different encryption keys so that all of the Oracle security technology works within a PDB. So I'm talking about encryption now, redaction, data masking, database vault, audit vault, all these things work within PDBs. So you can have different encryption keys between these customers. And what that means is that even if customer two could get their hands on the files from customer one in some extraordinary way, I can't imagine what that would be, they couldn't read it anyway because they haven't got the encryption key. This sort of thing is all very important. And then the next thing is you think about how the multi-tenancy is delivered. The way the multi-tenancy is delivered by multi-tenant, by Oracle multi-tenant, is that the tenant would come straight into their PDB. And for example, if you think of something very simple here, I'm going to say, I'll do, tenant two comes along and says, show me my orders. You can imagine the application writing a bit of SQL that says, select star from orders. And it just runs it in customer two's PDB. That's how you get the data from customer two, right? Now, let's talk about another way of doing multi-tenancy. The way Salesforce does it, or NetSuite used to do it. The way Salesforce still does it is that they have the application deliver the multi-tenancy. What they do is they just have one big database, and everyone's data is sloshing around in that same database. And the way you tell the difference between customer one's data and customer two's data is they have something that looks like a tenant ID column in every table. So my example was, show me my orders. In the Salesforce model, you say select star from orders, where tenant ID equals customer two. It's very clever. The application adds that little predicate to the SQL statement to make sure that you retrieve just that customer's data. And it really does work very well, as long as you only come into the application, to the database via the application. But what this means is that you can't just run around inside the database with something like Tableau. You can't build custom reports. You can't get in there with SQL Plus because everyone's data's there and it's vulnerable. So it makes application extensibility and browsability much, much harder. Whereas with our model, you can come straight in and you're guaranteed to be working in your own isolated environment and have no access to anyone else's data or vice versa. So it's a really great, great use case. So next up, distribution of packaged applications and data. It's kind of old hat. That's the way we've done things at PeopleSoft. New version comes out, we literally stick a version in an envelope or something, or maybe they download a PDB, you plug in your new one. These days, it's all about moving to the cloud, which I suppose is the next thing. So again, with PeopleSoft, these days we're talking about lift and shift to the cloud. So people have got various applications, including PeopleSoft, let's say, on-prem, and now what they're doing is they're moving that database into the cloud. Not literally as I've drawn it here. This is supposed to be illustrating dev and test, but they might just be, retiring all of their on-prem equipment and replacing it with capacity in Oracle Cloud. That's the way you'd move PeopleSoft there. And a final use case to talk about is something I call sandboxing. So in this case, it's all about doing analysis of very, very large data sets. But some of that analysis it is fine to run in a production system. Some of it's destructive. And this is the sort of the what if type analysis. I talk to banks about this use case a lot. What if the consumer price index changes by 5 points? What if, Brexit happens or something similar happens? There's going to be some massive change in exchange rates. You can't make those sorts of changes in the production database because it affects everybody. So what you need to do is create a clone. And then with these huge databases, you're kind of faced with the problem of having to create, a full clone of an entire database. In this case, I'm trying to show a data mart. These things can easily get into the terabyte, tens of terabytes, hundreds of terabyte range. And copying a database that big is a very hard thing to do. It's expensive. So you end up having to cut corners. You either take a subset of the data or you've got stale data. But what they really want is they want to operate on all the data, and they want to operate it on it right now. And this is where the snapshot cloning comes in. So what we can do is we can take a production data warehouse, even a massive one, create a snapshot clone of it very, very quickly. So you provision in an instant, and then you do your analysis at the speed of thought. If you're using something like Oracle Database in memory, which works fine with multi-tenant, so you can do this analysis very, very quickly. When you're done, you throw it away, take a new clone, in this case a subset clone, the same sorts of thing. Works great with database in memory. So that was a quick run through, maybe not so quick run through, of some use cases. And the idea of going through all of this was to give you some food for thought if you're thinking about where to start with multi-tenant. In all of them, you're going to get some mix of these benefits, and typically all of them. You minimize CapEx because you can get more applications per server, capital expenses that is. Minimize operating expenses because you can manage many as one. You increase agility because of the speed of provisioning and portability that we've shown. And it's easy to use because the interface is SQL, and it's easy to adopt because the applications run unchanged. So those are your benefits. These few slides illustrate how snapshot clones work, or how copy on write works. So basically, let's think of just a full copy of a data file. A file, what is a file? It's basically a copy of data blocks, a set of blocks, and some headers, which basically point to all the blocks in the file and say, this is what my file is made up of. Right? So if you're going to take a copy of that file, the sort of simple way of thinking of that is you copy all the blocks and all the headers. Nice and easy. Everyone understands this. But it's expensive because it is literally a copy of everything involved. And that means you duplicate the storage. It's 100% extra storage. And it takes all the time it takes to write all of that data. So the thinking about copy on write technology is to cheat a little bit. You say, okay, this is what my file is made up of. But now, to create what's apparently a copy of my file, all I'll do is I'll copy all the headers. And I look at my file, it's called my file. You look at your copy, my file copy, appears to be two different files. But in fact, we can see that under the covers, we're cheating. We're just pointing to the same set of blocks. Okay, so far so good. Now to Judith's question. What happens when someone makes a change? What happens then is you copy the block in which you've made that change, and you point just that part of the header to the changed block. So everything else points to, everything that hasn't changed, the headers just point to the old blocks, the single set of blocks. But it's where the change has been made that we point to the changed blocks. So that's why it's called copy on write. When you make the write, that's when you copy the block, but not beforehand. So I hope that explains it, Judith. So just under the covers, that's basically what we're doing. And it works very, very effectively. We're just doing it with our data files that underlie the table spaces. No, it doesn't affect performance adversely at all because you're just coming in and you're looking at the same blocks. Now, I mean, I suppose there is a risk if you've got, let's say you've got 1,000 people. I'm making this up. Let's say you've got 1,000 people hitting a production system, and you've got 1,000 developers, and everyone is using. Let's say nobody makes any changes, so everyone. Now you've got 2,000 people accessing the same blocks. There is the potential there. That you will have additional strain on the I/O, and indeed, potentially the compute resources of that production system. So that's why the typical model is the way I illustrated it: that you take a clone master from production, So you leave production on its own, you have a clone master, which, a golden master or development master. And you'll find that the performance works just fine. So there are a couple of use cases I think are really particularly well suited for snapshot cloning. One is dev and test, and the other one is that sandboxing case that I talked about. How easily can PDBs be moved to different servers containers? Very good question, Tyler. Very simply, you can do this. There's a capability we have called PDB relocate. So what you do is you go to the target CDB, and then you say, create pluggable database, my PDB from my PDB at database link, and the database link points to where it currently is, its current source. Relocate, so create PDB, my PDB, from my PDB at database link, relocate, and it just moves. As far as the customers are concerned, nothing changes, the applications don't stop. What we literally do under the covers is to take a clone. When the clone is finished, we bring it up to speed and we forward the connections. But that happens very nice and quickly. There's another set of slides on YouTube actually, which I can share in chat, which explains that in some detail. Next question is the instance viewer for the database. How well does it break down statistics for each PDB? Okay, yeah. So actually, this question is quite perceptive, Tyler. First of all, yes, we can see statistics at an individual PDB level. But I think beyond that, let's say you identify that one of the PDBs is hogging the resources. Can you control the way the resources are distributed between the PDBs? The classic problem.
Yeah, that was another question I was going to ask, actually.
Well, I anticipated it. I can see where you're going here. You don't want the noisy neighbor problem. And we've got a capability called Resource Manager, which allows you to build limits around each PDB. Very simple to set these policies up. Let's say you're in an Exadata, like Yai is with Wells Fargo. So Exadata, you've got something like, I don't know, 44 cores per blade, and tons of these things, so 88 and a quarter rack, and it goes on and on. So you put an individual PDB in there, and you say, I only want this PDB to have access to four processors. So you say, alter system set CPU count equals 4, that PDB. That's it. So you can't step outside those bounds. It basically limits your resource consumption. It's really cool. So you do it for CPU, you do it for IOPS, sessions, parallel execution servers. You can even limit memory this way. All sorts of stuff can be done this way. Very important.
Awesome.
Very important capability with a limitation. Yeah. And with that, we come pretty much the top. So where are we with Huang? Can you help with this one? 18C refreshable snapshot clone PDB. Yes. So the cycle of refresh of PDBs in 18C is the same as it was in 12.2. You have to close it to refresh it. So you go close, refresh, open. Open, read only. Close, refresh, open, read only. Close, refresh, open, read only. That's the cycle. It would be nice if it could stay open, read, write. But to do that, we'd be using technology very similar to Out of Data Guard. And then we'd be in the business of having people pay for Out of Data Guard licenses. That's not necessarily such a popular thing to do. So that's the way it is for now. Yeah, if you don't mind, I'll start with you. I'm going to unmute you and ask if you would say hi and tell us what you're doing with multi-tenant.
Okay. Wow. Surprise. Can you guys hear me okay?
Very clearly. You've got a very good microphone.
Okay. We consolidation. We use it for consolidate different application onto the Exadata.
Oh, very good. Are you using Exadata on premises, or are you using an Exadata cloud machine?
Well, you have to explain what the difference. I didn't
Well,
get that.
the simple difference is that an Exadata cloud machine is owned by Oracle, and you pay to rent it, or to operate it on a cloud subscription basis. Another machine that otherwise you buy your own Exadatas.
We buy our own Exadata.
Oh, you buy your own Exadata. Which company do you work for?
Wells Fargo.
Oh, Wells Fargo. Okay, great. Oh, of course. Okay, I know them very well. Apart from anything else, I've been a customer for 29 years, I think.
Oh.
Okay, great. All right, then okay, well, maybe we shouldn't go too deep into that, but yeah, we're very proud of our installations at Wells Fargo. You probably know we've had several presentations at Open World with Wells Fargo. Are you involved in that deployment team?
Well, I don't do much, but teammate does. We have specific application where each one of us support. Our team does all the infrastructure side. So migrations from standalone into Exadata. Which recently did a couple of applications that were kind of ongoing process, moving other apps to Exadata. So that's our main purpose. So that we had to run into issues where performance issue. We found out that last time we had something. System statistics. We are not sure that we had a few issues. So someone recommended that you probably should collect the system statistics. But then later on, we found out that on PDB level, when they collect system statistics, there's nothing collected. So we were wondering, can we collect system statistics on the PDB level, or can only be done in the CDB level?
Well, that changed from 12.1 to 12.2, as you probably know. In 12.2 now, we do allow you to collect some stats. Are you talking about AWR now?
You mean the application?
Yeah, collecting the stats specifically. Are you talking about AWR data?
No, it's no. The system statistics, like how many core you have, the server itself, the I/O. What's that again?
Oh, you're talking about monitoring within the Exadata.
Right.
Yes. Okay then.
So that was just something we haven't done that. So we found out that it doesn't appear to be that way. I think most of our database on 12.1, not 12.12 yet, 12.2 yet. It's just the limited things that we can do, and then we have different level of support. Like there's PDB DBA and there's a CDB DBA. There are different levels, and it's hard to figure out who can do what on what level.
Well, yes. I mean, the point is that it's very configurable. Sorry, my video keeps flashing in and out, and I'm going to try and make it so it pins. I thought there was a way of doing that.
Yeah. It's stable for me.
Oh, it is? Okay,
yeah.
That's good. For me, it's rather disconcerting because it flashes in and out.
So I was wondering if you can give us some pointer on like performance tuning, for PDB on Exadata, and that will be wonderful.
Yes. Okay, then that's a very good topic. So I'm going to write that one down.
Some tips.
Performance tuning on Exadata. All right then. Thank you, Ya. Is Ya am I correct addressing you correctly?
Yes, correct. Thank you.
Okay, good. All right then. So let's see who's next. I'm going to go. Kurian, I'll go to you next, if I may. So I will unmute you. Welcome to our little party here, Kurian. Where are you from, and what are you interested in talking about here? For some reason, I can't unmute you. Can you speak to us, Kurian? Oh, there you are.
Are you able to hear me, Patrick?
Yes, very clearly. Thank you for joining us today. How are you?
Yeah, doing well. How are you?
Good, thank you.
So I'm based in Austin. I think we did meet in one of the sessions recently. So I'm just here to hear from you on the multi-tenant capabilities and things like that.
Okay. Yeah. So today's session, I didn't really have any specific topics that I wanted to discuss today. I just thought, we'll do this as the name of the session suggests. Office hours, come and make a request. The danger is I'm going to get myself in trouble and someone's going to ask me a question that I can't answer. But maybe as we go through these other things, Kurian, you'll hear something of interest, or if anything pops into your mind, feel free to dive on in. Okay, so thank you. I'm going to mute you and I'm going to move on to Judith. Hello again, Judith. I remember talking to you 2 or 3 months ago, I think, when we did this session. Okay, I see a hand up. Okay, DBMS stats. Judith, can you hear me? Perhaps not. Okay, well, let's move on then. Huang, your turn. Hello, Huang.
Hello.
Hello, welcome to our little party here.
All right. Actually, I do have a couple of questions about the mechanics about the application PDBs.
Specifically underneath application root?
Yes.
One of my favorite topics.
So let's see. Right now, I think when I'm doing my test on the application, install application, sync application, that's okay. But when we actually do the real deal, let's say if I have a table with terabytes of data and try to modify the table using the regular outer table, whatever the thing is doing might not work very well. So is there an alternative way of doing the application sync? Let's say if I can manually override it or somehow.
Well, actually, I think your concern is not well founded. So perhaps what we'll do is we'll go through the process of sync and how that actually works, so we can understand how what will be the implications for a large data set. So we'll come to that. Okay, excellent question. So application container in general, specifically application upgrades with large data sets.
Yep, and the difference between the upgrade and patch. Okay,
good question. Upgrade and patch. Actually, what I should do is probably share this. No, I won't. Never mind. All right then. Very good. Thank you, Huang. And where do you work, Huang?
Boston, from Athena Health.
Athena Health in Boston?
Yep.
And where are you in the? Okay, I'm interested in your deployment use case.
Yes. Right now we have roughly 100 production DB, and they are all in 4-way data guard mode, so 400 database total. And right now we are doing the schema consolidation. I'm trying to move it to PDB consolidation with application, of course.
Okay. So you said 100 production databases in a data guard configuration.
Yeah.
Okay, schema consolidation, you're moving to application container. And if you're thinking about application container, you're thinking about SaaS, is that right?
Correct.
So what's the business model there? You're replicating business practices across multiple schemas, soon to be PDBs. Each schema belongs to, what's the sort of class of tenant? Is your customer something like a clinic or a hospital?
They are. We have both a clinic and hospital. They're using the same schema definition.
Okay, and clinics. Okay, very good. Yeah, we've done quite a lot of work with other folks in your space. Specifically, McKesson is doing a very similar thing. So we can talk about that. Very interesting use case. Multi-tenant and application containers are perfect for that. Thank you. All right then, let's see. Tyler. Hello, Tyler. Don't think we know each other. I'll say howdy and I'll unmute you. What are your interests with multi-tenant?
Hey, I'm sorry, what was that?
What are your interests with multi-tenant?
Work interest, I suppose. So we're actually moving over to 12C architecture, or 12.2. We're going to start using the pluggables. So I'm trying to get a little bit of understanding. I previously attended one back in February, I believe. So I'm just still trying to wrap my head around what exactly it is.
Okay, so early in the deployment cycle for you. And where do you work, Tyler?
I'm actually an intern at FedEx.
I had a good talk at Collaborate a year or two with a lady from FedEx. Okay,
Mm-hmm.
so you're an intern there. Okay, cool. So you guys have have you bought multi-tenant and you're figuring out where to start, or are you still?
Yeah. So actually, they've been partially deployed, but we're just trying to get everything over to it now.
Okay. Okay, so you want to know more about multi-tenant in general.
Right. Yeah.
So there's a whole bunch of chat here. So Alexandra said he's here, but now he's gone. A couple of things from Yar. Oh, okay, so Judith can only use chat. Basically, she's trying to learn both from my presentation and others' questions. My purpose is to be able to manage a database by myself, me being a developer and not a DBA. Okay, well, maybe we should just start with a very brief little introduction, certainly for Judith and Tyler's case, just to talk about use cases of multi-tenant, just a sort of overview of what can be done, and then that'll bring us towards specifically towards application containers. That'll allow me to address Huang, and then we'll talk about we'll talk about performance, because I think by the time you've been through the architecture, we can talk about some performance tips as well. And you're talking about collecting stats. And actually, before I go on, I just want to confirm, I think you already said this, but when you say you want to collect stats at the PDB level, are you talking about outside of what AWR can do? You may need to unmute yourself. I'll do it for you.
Yes, you are correct. Outside AWR.
So what is it that AWR doesn't give you that you want?
The AWR is more like, for us, we feel like it's more like within the PDB, but we also feel like this on the system level, knowing how many cores the machine have, or the back end, the I/O activity, the speed, the write latency, read latency, all that stuff, all affecting how the optimizer chooses execution plan. It has overall impact on all the PDBs under one CDB, and that's why we were thinking. We're kind of shooting in the dark. We're not sure that will be, but we migrated to Exadata, the particular application. We haven't collected any system statistics. We were just thinking, hey, that could be the cause why a query used to run in 3 seconds now run an hour.
Oh yeah, I mean that's going to be a query plan. That'll be a plan change. Anything of that magnitude will be an execution plan.
Okay.
That's what's going on with something like that. It's very unlikely to be something at the system level. You see marginal things at the system level. A few percent here and there, but you wouldn't see massive changes like that. If it takes 20 times longer, 3 minutes to an hour, that's execution plan. And so what you should be looking for there is the query plans. It's typically going to be an issue of how the stats have been gathered and how stale they are. That's my suspicion.
So you're recommending we compare the execution plan before
Yes,
and after?
yeah.
Okay.
You'll find the execution plan is different.
Okay.
That's almost anything of that magnitude. It's almost certainly going to be an execution plan issue.
Okay, I'll go that route. Thank you.
Okay. And it may be that what we have to do is to arrange a session with one of our performance guys to help you do some assessment. I know that you've got some consultants there, haven't you?
We do, yes.
Yeah. They should be able to provide some guidance there. You shouldn't have to be shooting in the dark about performance.
We're so many applications, each one of us trying to engage them. And they have to go through certain levels approval. Okay.
Oh, I see your point. Okay, then. Well, it may be that what would be good would be to arrange just a general session about performance tuning in Oracle Database.
Well, I mean, for me, it's more like the PDB in Exadata. They were kind of different when they in the Exadata was a standalone, container database. They're acting differently.
Okay.
So, but if you have any links that I can read, just you can post them to your PDB on Exadata or somehow the PDB and Exadata, and I would love to read them.
Yeah. So actually, there's some good little tips that are coming in on the chat. I like this. I should sit back and drink my coffee. In fact, I think I'm going to press the mute button here because Huang has come in with a very good suggestion about using SPA, the SQL Performance Analyzer. And Kurian is pointing you to a blog by one of my friends here, Maria Colgan, SQL Maria, should you gather system statistics. So she's very good. These are excellent places to start. Oh, yeah.